This is Jacob's Algebra, Chapter 13, Lesson 4, Solving Quadratic Equations by Factoring. Now we have a new rule we're going to learn in this lesson. It's called the zero product property. And the basic idea behind this is if you take two numbers, whoops, that's not writing. If you take two numbers, A and B, and multiply them together and get 0, then either A has to be 0 or B has to be 0, because you can only get 0 by multiplying when one of the things that you're multiplying is 0. So the zero product property says if A times B equals 0, then either A equals 0 or B equals 0. What if we have something like x squared minus 2x minus 3 equals 0? How could we solve that? Well, in the last lesson, what we worked on was solving this by graphing. So we chose values for x, we computed values for y, we changed this to x squared minus 2x minus 3 equals y, and we graphed that equation. And wherever that graph crossed the x-axis, those would be values of x that would make y equal to 0, because on the x-axis, y equals 0. So you can solve this by graphing, but graphing often takes a really long time when you go through and choose a bunch of different values for x, and you might not choose x values that are in the right range so that you will get y values that are 0. So what we're going to do now is learn how to solve this algebraically. And the way that we solve this algebraically is to factor our equation. So looking back at x squared minus 2x minus 3 equals 0, what we're going to do is factor the polynomial. So we're going to figure out what we have to multiply together to get x squared minus 2x minus 3. Well, we know that we're going to have x times x to make x squared. Now what we have to do is find two numbers that multiply to make negative 3 and add to make negative 2. Well, what things multiply to negative 3? Well, the numbers that multiply to 3 are just 1 and 3. And because it has to be negative, that means that one of these has to be negative and one of these has to be positive. Since we need to add the two numbers to get negative 2, the bigger one has to be negative. So we're going to say negative 3 and positive 1. And if you do multiply this out, you will get x squared plus x minus 3x, and plus x minus 3x is minus 2x, and then minus 3, because negative 3 times a positive 1 is a negative 3. Now you can also solve this using the grid method, which we've done many times. So just to show you again really quickly how the grid method works, to solve this equation using the grid method, we know we're going to have x squared in the top left box and we're going to have negative 3 in the bottom right box. And we need to figure out what numbers we can put in the other boxes to make our equation. So what we're going to do is take our coefficient here, which is 1, and take our number here, which is a 3, and that multiplies to 3. The only factors of 3 are 1 and 3. Since this is negative, that means we need to subtract these numbers. And the bigger one has to be negative because we have our middle number is negative. So that means the 3 has to be negative. So we'll do a negative 3x and a positive x. And then we just find the greatest common factor of each row and of each column. In the first row, the greatest common factor is x. In the second row, the greatest common factor is 1. In the first column, the greatest common factor is x. In the second column, the greatest common factor is negative 3. And you see we get x minus 3 times x plus 1, which is just what we have over here. Now, because x minus 3 times x plus 1 has to equal 0, that means we can use our zero product property to solve the equation. X minus 3 is a factor and x plus 1 is a factor. That means that x minus 3 equals 0 or x plus 1 equals 0. Either one of those will make our equation true. And we need to find all the values where this is true. So we're going to look for both values of x. If x minus 3 is equal to 0, we can add 3 to both sides and get x equals 3. If x plus 1 equals 0, we can subtract 1 from both sides and get x equals negative 1. That means our solution is x equals negative 1 or x equals 3. So both of those are solutions to this equation. So just to go through the brief rules on how to solve an equation by factoring. The first thing you have to do to solve an equation by factoring is write it in standard form. Now, writing it in standard form means that you've got to write it in ax squared plus bx plus c equals 0. So you need to have the right side of the equation needs to be 0, and on the left side you need to have everything written in descending powers. Now, I will also say that it will be much easier for you to solve if you have a positive number in front of your x squared. So if you end up with something like negative 2x squared plus 3x minus 4 equals 0, do yourself a favor, go ahead and flip all the signs. If you multiply both sides by a negative 1, what that's going to do is flip all of your signs. You will have 2x squared minus 3x plus 4 equals 0, which is an equivalent equation and will be much easier to solve than one that has a negative in front of your x squared. So please do yourself a favor. If you start off with a negative number, after you've got it written down, go back and flip all of your signs. But you have to flip all of them. You can't just flip one of them. All the signs have to be flipped. Okay, so that's the first thing you have to do to solve an equation by factoring. You've got to write it in standard form. The next thing you have to do is factor your polynomial. Use a grid if you need to. Grids are perfectly fine. And then the next one is to set each factor equal to 0, which you remember we did right back over here. We had the two factors, x minus 3 and x plus 1. So we set x minus 3 equal to 0, and we set x plus 1 equal to 0. And then we solved each of those equations. And x can equal both of those values to solve this, to make this equation 0. So both of these are solutions to the equation. Okay, so next thing we need to do, once you've solved the equations, you've got your values for x. So let's do one more of these just as an example before I get to the problems we're going to work out. Whoa, sorry, I didn't mean to do that. Okay, so the next thing we're going to do is just try an example. What if we have 3x squared plus 20x plus 3 equals 10? Now, we can't solve this yet because we don't have it written in standard form. Standard form, remember, the right side of the equation is 0. The polynomial is on the left side, and everything is written in descending order. So to get rid of the 10 over here, we have to subtract 10 from both sides. So we will end up with 3x squared plus 20x minus 7 equals 0. Because when we subtract 10 from 3, we get negative 7. When we subtract 10 from 10, we get 0. Okay, now to solve this equation, this is kind of a complicated one. So what I'm going to do is go ahead and draw a grid. So I'm going to draw my grid over here. Always use a grid when it's complicated. And we know that the top left box is going to be 3x squared. And we know that the bottom right box is going to be negative 7. Now we have to figure out what goes in these other two boxes. So what we need to do is multiply the 3 by the 7 to get 21. And we've got to find all the factors of 21. Fortunately, there's not many. We have 1 times 20. And we have 3 times 7, and that's it. Now, since there's a negative sign here, see the negative sign? That means we need to subtract our factors, and we need to subtract the factors to find 20. So that means we're going to use 1 and 20. And because this is a positive number, it means our bigger number has to be the positive one. So we're going to have 20x and negative x. Okay, now we need to find the greatest common factor in each row and in each column. I'm sorry, I have a 20 here. That's 21. I don't know what I was thinking there. 1 times 21 is 21, not 1 times 20. So our greatest common factor in this first row is 3x. Our greatest common factor in the second row is negative 1. The greatest common factor in our first column is x. The greatest common factor in our second column is 7. So the way we would factor this is 3x minus 7. And again, I'm making another mistake. Okay, let's try this again. 3x minus 1 times x plus 7. So now, and that equals 0. Now, by the zero product rule, anything that you multiply together to make 0, each of those factors can be 0. So we're going to say 3x minus 1 equals 0. And we're going to say x plus 7 equals 0. So now we solve each of these equations for x. For this equation on the left, if we add 1 to both sides, we get 3x equals 1. If we divide both sides by 3, we get x equals 1/3. Okay, the equation on the right, if we subtract 7 from both sides, we get x equals -7. So those are our solutions. X equals 1/3 and x equals -7 are both solutions to this equation. So if you plug either one of those back into the original equation, you'll find that it's true. Okay, now let's work some example problems actually given in set 2. So number 4 is the first one. Number 4 is just like number 7. The thing you need to be careful of is that they don't actually show you that each of these is equal to 0. What the instructions say is what values of x will make each of the following products equal to 0. So what they show you, and I'll do part A as an example, is x minus 4 times x minus 5, and that's it. You need to know that this equals 0. In number 4, which is just like your number 7, everything equals 0. So you can go ahead and write equals 0 for each one of these. Now, it's already factored for you, which is really nice. So number 7 should not be bad because everything's already factored. All you have to do is use the zero product rule. We're going to take the first factor and set that equal to 0. So x minus 4 equals 0. And we're going to take the second factor and set it equal to 0. So x minus 5 equals 0. Now we solve each of these equations. With the equation on the left, I just add 4 to both sides to get x equals 4. The equation on the right, I add 5 to both sides to get x equals 5. So x can equal 4 or x can equal 5. And actually both of those are solutions. X equals 4 and x equals 5 are both solutions to this equation. So let's jump down to part B. For part B, we have x times x plus 8 equals 0. Now this is one where I see a lot of people make a mistake. Most people will look at the x plus 8 and say x plus 8 equals 0. But this x is a factor also. Anytime you have an x by itself being multiplied, then you have to set x equal to 0 also. Because if x equals 0, this equation will be 0. So x equals 0 is one solution. X plus 8 equals 0 is another solution. If we subtract 8 from both sides, we get x equals -8. So the solutions to this equation are, I don't know why I drew a parentheses, x equals 0 and -8. Both of those are solutions to the equation. Now let's go down to part C, number 4C, and we have 3 times 2x minus 1, and then you have to write the equals 0 part. Now here, again, you can use the zero product rule, but 3 equals 0 doesn't make any sense because we know that 3 can't equal 0. 3 is a number which is not 0. So we don't have to do anything with the 3. We just look at 2x minus 1 equals 0 because we already know the 3 does not equal 0. Now to solve this equation, we add 1 to both sides. So we get 2x equals 1. And then to get the x by itself, we divide both sides by 2. So we get x equals 1/2. So this equation has only one solution, which is x equals 1/2. Okay, now let's jump down a little bit and do number 4, part F. So number 4F, and the equation there is 8 times x minus 4 times 8x plus 2. 8x plus 2, and you have to say that equals 0. Okay, we've got 3 different factors here that we are multiplying together to equal 0. But we know that 8 does not equal 0, so we can ignore that one because 8 doesn't equal 0, so that's not a factor we have to be concerned with. But x minus 4 can equal 0, or 8x plus 2 can equal 0. So to solve the equation on the left, I add 4 to both sides and get x equals 4. To solve this equation on the right, I subtract 2 from both sides to get 8x equals -2. And then I divide both sides by 8 to get x equals -1/4 because we have -2/8, which simplifies to -1/4. So our solutions are x equals -1/4 and x equals 4. Those are our 2 solutions for part F. And now let's go ahead and do parts G and H because those are kind of special. Number 4, part G, we have x plus a times x plus b is equal to 0. We can still solve this.